My name is Kwame, and this is Can Androids Conceive of Electric Sheep? Today I'm going to talk about a series of experiments I tried to kind of explore artistic expression. But first I'll tell you a little bit about myself. I've always kind of had a fascination with creating and sharing. I remember being a kid and staying up until late hours of the night, writing and drawing stories. When I got tired of playing with my toys, I actually used to make my own toys out of household objects. And they were so good that people offered to buy them from me. It was kind of crazy. When I was in middle school, I took up an interest in trying to make video games, so I took a C++ course and really fell in love with programming. It's really an unparalleled way to create and share, which is really important to me. And really, programming is kind of a superpower, right? Especially these days. So you share the right thing, and all of a sudden, everyone in the world sees it. So I've been obsessed pretty much ever since. So I've worked on a lot of different types of software since I wrote my first line of code, including instant messaging and social networking. But ultimately, really, the same things motivate me as they did when I wrote my first line of code. I'm really all about exploring the margins of knowledge and trying out new ideas and really just asking what if. And that's really what this talk is about. I asked what if, and we'll see if I asked what if too many times by the end of the talk. So several years ago, I was working on a photo sharing app, and I had an idea. What if we create a secret URL where people could go and see their photos appearing before their eyes? And I didn't know exactly what that meant, but in my mind, it maybe was a sketch or some sort of painting or something like that. I thought it'd be really fun for people, right? Unfortunately, that company was against Easter eggs, but the idea really stuck with me for a while. So shortly after I conceived of this idea, I was at a weekend hackathon and decided to give the idea a try. Had the rough idea in my head, it had kind of been bouncing around. I figured try edge detection, consider the pixels sort of a graph of connected nodes, and do a depth-first search. Really had no idea what I was doing, but downloaded OpenCV, fired up Vim, and a couple hours later, I had a really rough working prototype. There we go. Okay, so the first version wasn't exactly what I envisioned, but it worked decently well. You got a sense of some hidden form slowly revealing itself, which is kind of what I was after. But the pixels being drawn just seemed kind of random. And it really just almost feels like a printer kind of doing its thing, right? So of course, the next natural step was to slow down the drawing speed a little bit, add a hand, maybe add pauses between the paths. And it's looking a little bit better. Movement isn't totally smooth, but it still feels pretty awkward, right? The drawing kind of starts in the bottom right corner. It's moving kind of randomly. I think we can do a little bit better. So I started to think carefully, like, what does it look like when I draw or when someone else draws? And I tried out introducing a notion of section ordering and path ordering. And that makes sense, right? Because if you're drawing an image or painting a picture, you kind of start in one section. And if you start with the longest paths, it's almost like you're drawing an outline, and then the shorter paths are the details. So all of these were just kind of rough proxies for the actual creative process. But I think it got me pretty far. So there is one more kind of nagging thing with this particular version as the hand moves in between paths. And I don't know if anyone else is picking up on that, but it does feel kind of awkward because when you're moving your hand, you don't really keep it close to a canvas, right? You kind of pick it up and put it back down. And so that was the last thing I added. And this is way overkill for a JavaScript prototype, but it was a lot of fun to work on. So something kind of funny happened when I got to this point. So this version of the hack actually far exceeded my original expectations, but feels kind of human-like, but not quite, right? So all of a sudden I just felt deeply dissatisfied with what I had done, even though it exceeded my expectations. It kind of reminds me of a thing from the Addams Family. I don't know if anyone remembers that. So I didn't realize it at the time, but this was the beginning of a descent into the uncanny valley. So as a quick refresher, the uncanny valley happens when you have a figure or some stimulus that feels almost human, but not quite. And it evokes that really eerie feeling. And there are lots of theories for why that is, but it's no trivial matter. When you're working on humanoid characters, you want to consciously avoid this uncanny valley. You either want to be extremely human or not lifelike at all, or else you risk kind of falling into this. So when this goes wrong, the results are pretty horrifying. Pretty horrifying. Let's go to the next slide. So of course, my hack isn't nearly as bad as that last slide, but there is something a little uncanny about watching this disembodied hand just zip around the screen, right? Now, I think most people, when they have that sort of uncanny valley experience, are inclined to head in the other direction. But I think as technologists, we sort of see it as a call to action, right? We're drawn to hard problems, to interesting problems. So I just had this urge to make this thing feel more human. Like, what can I do here? What will it take to climb out of this valley? So reflecting on it, I figured the challenges kind of fall into two buckets. So the first is human cognition, right? How do people think about the process of drawing? And the second is human biomechanics. Mechanically, what are they doing? How are they moving? Answering those questions would be vital if I wanted to make my way out of this valley. So around a year later, I started working on a really small iOS game. And the basic premise was that you watch an image being drawn, and you try to guess what's being drawn as quickly as possible. And the faster you guess, the more points you get. So I figured this would be a cool way to turn that little crappy weekend hack into something a little bit more. And at first, my interest was primarily in designing a really engaging game experience. But as you can probably predict, I started to fall into that uncanny valley again. So the prototype with a hand was a pretty good start. But as we already saw, watching a disembodied hand draw photos is just a little bit weird, maybe even a little bit creepy. So what I need here is probably just a whole arm. So how do you implement something like that? What if you model it as a chain of joints? So we already have this stream of pixels, right? And that gives us the position of the hand over time. So if you have the position of the hand, maybe you can work backwards and figure out the rest of the arm. So I started with this prototype just to refine the math and validate my assumptions. And the math behind the arm movements is pretty straightforward, right? So you have 4 known values. You have your shoulder position, you have your hand position, you have the length of your humerus, and the length of your ulna and radius, right? So we essentially want to figure out the position of the elbow, and that's going to move the further away our hand gets from our body. And you can think of the length from your shoulder to your hand as sort of this third side of a triangle that includes the other parts of your arm, right? If we know all 3 sides of a triangle, it's pretty easy to figure the rest out using the law of cosines. So I won't spend too much time on this, but breaking it down to geometric terms works really well because it's a really concise way to encode the constraints we experience in the physical world. And this was a really important lesson for me. So coding this was a lot of fun, and seeing the working prototype come to life was pretty motivating. I'll show you that in a second, but first, what I didn't realize is that all I was doing was actually recreating a really well-known process in computer animation and robotics. It's called rigging and inverse kinematics. So rigging is the process of taking a model, it could be a human, it could be an animal, it could be a robot, but taking a model and designing an interconnected skeleton so that you can easily pose it in many different poses without having to animate the whole thing all over again. And then inverse kinematics is about basically moving an end actuator, which is just a fancy robotics term for hand. So you move your hand around, and that basically helps you orient the rest of your body. So that's a much more formal definition of everything I just described. So both rigging and inverse kinematics are absolutely foundational to the area of computer animation. IK is a really efficient way to code a lot of these complex animations. I'll talk more about that in a second. But it's also a really important piece to the uncanny valley puzzle. There's actually an entire ecosystem of software built around helping engineers put IK into realistic character animations. So here's what my inverse kinematics implementation looks like on iOS. This was undoubtedly a leap forward from the disembodied hand approach, right? And seeing an arm attached does feel pretty cool, but the animation still doesn't feel quite lifelike. I'll give you a second to watch this. And this is a sculpture being drawn, the thinker. But also, watching that arm move around just feels kind of weird. I mean, part of it is a little bit of animation jank, but I think we're still maybe sliding back into the uncanny valley. So at this point, I had a long backlog of really small tweaks to implement to make this feel satisfactory, and each one represented such a small step out of that valley that I became a little bit less bullish on this idea. And I really concluded that making this feel satisfactory would probably require 3D rendering or something a little bit more advanced than what I'm doing here. So before moving on to the next section, I want to take a quick detour to kind of set the stage for the rest of the talk. So I'll tell you what happened next in a moment, but before doing that, we really have to talk about Bob Ross. So Bob Ross is best known for his show, The Joy of Painting, ran for 31 seasons over 11 years, ended in 1994. In this show, Bob teaches you to paint primarily using the wet on wet technique, which is a really forgiving technique, so beginners can create things pretty easily that they're pretty proud of. So if you've ever seen Bob Ross, you know he's known for his calming, smooth demeanor. Bob passed away in 1995 at age 52. And for context, there were only 16 million users on the internet. This was 3 years before Google was founded when he died, and 10 years before YouTube was founded. And yet he has tons of memes floating around, a series on Netflix, and over 3 million subscribers on YouTube. That's how much of a badass Bob Ross was. But I digress. Bob Ross deserves a shout out today because he taught millions of people the joy of creative expression. He taught us to use our imaginations, to savor the moment, and to enjoy life's happy accidents. Watching him paint was a little bit like watching a magician. You watch the scene come to life, and it just seems like he's just effortlessly flicking his brush around, just humming to himself. It's kind of incredible, and he does this in less than 25 minutes. I mean, think about that. Can you even cook dinner in less than 25 minutes? Can you finish a meeting in less than 25 minutes? I think not. Imagine Bob Ross outside painting this before you finish your meeting. So the other thing he taught us was that it is kind of enjoyable to watch this creative process play out. I mean, he starts with this blank canvas and he's just living in his zone of genius. Even when you're not an active participant, this is a really special thing to be a part of. So as we continue to talk about emulating the cognition and biomechanics of an artist, we're kind of talking about creating a virtual Bob Ross. So as I began to think about making a 3D version of this program, I learned a lot about the world of 3D animation, including rigging, which I mentioned, inverse kinematics, motion capture, a bunch of 3D game engines, and much more. And I began to saw a little bit of light at the end of the tunnel, or at the top of the valley. And I began to imagine how this would work. The disembodied hand approach feels really weird. So would a disembodied arm approach feel any different? I think disembodiment might be the uncanny thing here, right? I concluded that the right next step was probably incorporating a full-on 3D model. So at this point, I had a good idea of how to architect it. I'd done the web version, I'd done the iOS version. After a little research, I chose a 3D game engine called Unity. So there's an abundance of resources and free assets available, and it's pretty easy to set up a basic scene, but 3D models have no inherent notion of movement. So they're inherently lifeless and inherently uncanny. So how can we fix that? Let's talk about how animations generally work. So the way to achieve complex movement in games or movies, it's actually not to create hundreds of nuanced animations. What people generally do is combine relatively simple animations in complex sequences and apply them to different body parts using different weights, using different timings. They basically build up these complex recipes to give you the behavior you're looking for. It's kind of like cooking. So blending animation is really a big part of how all these dynamic characters that we're all accustomed to come to life. In this example, it's relatively simple. There are just two animations. There's running and jumping. But what's actually happening is as the character begins to jump, that run animation is phased out, and when they land, it's phased back in. And 10 years ago, or probably 15 years ago, this wasn't that common. So 15 years ago, this would have been magic. Today, we just take it for granted. But there's a lot of sophisticated math actually going on in the background, an interpolation between different animations. And there are just two animations here, but you could, in theory, have dozens or maybe hundreds of animations in some cases. So as a result of this sort of blending behavior, we get nice, smooth, and natural, maybe not lifelike in this case, but very natural feeling movement. So what kind of recipe should we be using for our artists? Let's talk about that. So here's what the scene looks like before the model has any notion of animation. So you can see a pencil sort of flying around the screen. But right now, otherwise, the scene is pretty basic. The only thing that I implemented kind of is the drawing speed is modulated so that at the beginning of the path, it's slow. At the end of the path, it's slow. So it kind of mimics that sort of natural drawing movement, right? So what should this sort of animation recipe for our artists look like? So the first thing I added was an idle animation. And this seems really mundane, perhaps, but this is actually super important. So the idle animation basically gives every single limb and fiber of this character's being something to do when I haven't told it what to do, which is essentially what we're all doing, right? So this is kind of the base layer of this recipe. So the next thing we want to do is animate the arm and hand. We already talked about inverse kinematics quite a bit. I mentioned there's already this rich ecosystem. It was a checkbox and a one-liner, which is really awesome. But here's what it looks like. So this is just, yeah. So this is just a weird nuance where the hand is defined as the wrist in the standard model. So we add in another layer where we tweak both the hand position and the rotation to sort of simulate what it's like to grab a pencil at different angles, right? Kind of torquing the wrist a little bit as you reach out at different angles. So this looks much better, but you might notice that the fingers are kind of idling still, right? I don't know if anyone can see that in the back, but what we want to do is kind of just curl the fingers to simulate pinching a pencil, right? So it took 4 ingredients just for that arm and hand to look somewhat realistic. So those look pretty good at this point, but what about the rest of the body? I don't know if you picked up on this, but as this arm is moving around, the character's face is just sort of staring ahead like this, right? Because that's just what it does by default. But then also the torso isn't adjusting, so when the character goes far to the left, it's kind of at this unnatural angle, right? So these are pretty easy tweaks, right? So we simply modulate the angle of the head to direct its gaze at the pencil, and that already makes a pretty huge difference in how natural the animation feels, unless you happen to be looking at the shoulders. So what do we do about that torso? So really we want to rotate the hips to account for 2 cases. We're going left to right. When the cursor is going left to right, we want to turn. When the cursor is going up and down, we want to bend back slightly and then forward, right? So this is yet another layer to add, but fairly easy to add, right? So once we add that in, then this is looking pretty good. This is looking pretty good. And when you see it side by side with that first sort of zombie-like version, the effect is even more pronounced. So there were more tweaks in this, and this was a pretty long process, but it's kind of fun to iterate on. Every time you add something, then it makes a huge difference. It feels a little bit more lifelike. And we can keep tweaking this indefinitely, but I'm going to stop here and move on to another challenge I encountered. So the next thing I want to talk about is path ordering. So I noticed the order that paths are painted felt subtly unnatural. So consider this figure. How would you reproduce this if you had paint, for example, or some other material where you could just paint over or draw over other layers? Well, for most of this image, it's pretty straightforward, but for the overlapping portion, it is a little bit tricky. A person would probably start with a blue circle, but by default, the computer just sees a blue crescent, right? Now, this isn't the most natural shape to draw. It's not impossible for an experienced artist, but if you don't have to, why would you, right? Path of least resistance. People intuitively understand that if materials allow, they actually have a pretty big margin of error because they're going to paint over certain regions of the image later. So when we have these overlapping objects, we don't actually have to get things 100% right. And it does feel a little bit weird when you have a really complex image and you have your sort of virtual artists drawing these intricate paths that just don't matter in the grand scheme of things, you know? So how can we make this feel a little bit more like human cognition? I think a human artist would probably do something like this, where maybe I need to get that left side really accurate, but the right side is just a blob. Who cares? I'm going to have a green circle, right? And green circle. It looks perfect. So how can we turn that crescent into a shape that feels more natural for a person to draw? So it turns out this required another implementation of that path generator I talked about. The depth first search wasn't really cutting it, and here's why. So what's happening is that, as I mentioned, all this computer sees with the depth first search is this crescent, which isn't that useful, right? It doesn't understand how it relates to other pixels in the image. So I used an OpenCV function called find contours. In OpenCV, a contour is really just a line, a collection of points. And sometimes those points close to form a nice shape, and sometimes they're just an open curve. But either way, they're treated the same way in OpenCV. And you can do some nice things with drawing, but they're treated the exact same way. So the really nice thing about find contours is that it gives us a contour hierarchy. And once you have the hierarchy, you can start to make inferences about the image topology. In other words, you understand a little bit about how those pixels are related to each other. So in this slide, you can see two types of subgraphs. It illustrates the two types of overlap. So we have the partial overlap, right? And that's on the left side. And then we have the complete overlap on the right side, or rather one contour completely within another. So the contour hierarchies for any image will contain dozens or hundreds of these subgraphs in addition to other types of structures. And you'll notice in the second case that those actually look pretty natural. So we're going to focus on that left side for now. So the next calculation is what I call coming up with a natural contour for the image. So there are two steps here. So we want to calculate what's called the convex hull for that contour. So the convex hull is the smallest convex shape that contains the entire contour, right? So if you don't remember that this is basically a nice way to fudge all the parts of the image that are difficult to draw, right? Because that smallest convex shape is basically just going to draw straight lines over any of the concave portions. And the concave portions are the ones that are going to typically cause us trouble, especially when they're part of these interlocking images, right? So we calculate that convex hull, and then we make sure that convex hull doesn't overlap with the visible parts of any other contours that are drawn earlier. If it overlaps with things that are drawn later, that's fine because it gets painted over, but we want to make sure it doesn't overlap with things that are drawn earlier. And here's sort of the net result here. And this is a really simple example, but on the left, you can see that original approach, right? Which doesn't feel that natural. And on the right, we have something that more closely approximates what an actual artist would do. So I started thinking about this because at some point, I'd love to port all this code to a robotic arm. And if I do all that work and it looks like the left side, then I'm going to be really upset. So that's why I started thinking about it. And this is obviously a stylized image on the right, just so you can see sort of the overlap. So moving on to another challenge, next I want to talk about image segmentation. And this is really challenging. It's a very active area of research. So far, I've been using simple edge detection to extract paths from the image. But that approach actually isn't that great. If you've ever tried edge detection on an image, then you know that you spend a lot of time fine-tuning parameters, and then you still encounter plenty of edge cases where it just doesn't work. So the big problem is that for some lighting conditions, you just get too many or too few edges. But then also, if you have an object in the foreground that's even somewhat similar to the background, they just kind of glom together, right? So when objects are drawn, sometimes we draw several objects at once rather than completing one object and then moving on to the other one, which just feels kind of weird. We still have sort of that printer effect. And even if this isn't using the section or path ordering I described, but even if it did, it would feel pretty random. Beyond that, though, it might be pretty useful later on to know what objects are in the scene. So what we want to do is segment the scene based on the objects it contains. So far we've been using pixel-based image segmentation, and there are lots of different algorithms you can use, but they all work basically the same way. You reduce the number of colors in the image, then you examine adjacent pixels and group the ones together that have similar color values. So most versions of this are simple and fast, but just not very accurate. What we want is actually fairly advanced, right? So it's not enough to know that the image contains a person because we want to know where the person is, right? And it's also not enough to know whether a pixel belongs to a person, because if there are multiple people in the image, we actually want a different object for each person. And this is called instance segmentation. That's what we actually want. Of course, this is something we can all do effortlessly, right? Because most of us can do this effortlessly because we have advanced visual systems. And in fact, it's kind of remarkable if you see something you don't recognize. Like if you look around the room, you probably won't see more than like one or two things that you don't recognize. So in the best case, this technique allows us to assign every single pixel to an object, exactly what we want. But this is a very active area of research, and even state-of-the-art techniques aren't that great yet. But of course, this is the technology that enables really advanced computer vision use cases like autonomous vehicles. Very active area of research. So in order to make this work, I had to implement yet another path generator. But I was relying a lot on Facebook AI Research's mask RCNN. So this time the path generator is responsible for identifying those objects, but then it hands it off to the contour path generator, and we get contours for the object individually. And then we also, well, actually I'll talk about the next path generator in a moment. So we're still reusing a lot of the same logic. So using this instant segmentation technique allows us to produce a much more realistic emulation of the artistic process. You can see in this example that discernible objects are being rendered, even though there's a lot of overlap, right, with the foreground and the background. After adding instant segmentation, I was pretty happy with this artist's ability to recreate scenes in a way that felt pretty similar to an artist's thought process, at least mechanically. But there was one more thing that was kind of nagging me about this artist. And that's that it was just regurgitating bytes on my hard drive. That's just kind of boring. There were some abstract forms being abstracted, but those are just mistakes, right? I was curious if I could take this a step further. Is it possible to introduce some notion of creativity? I genuinely didn't know, so I looked to the world of generative art for some inspiration. So in case you're not familiar, here's a frequently cited definition. Art programmed using a computer that intentionally introduces randomness as part of its creation process. That sounds like the right direction. Okay. So here's a really early example from 1968. You can see how the squares start out uniform at the top, and then towards the bottom, the position and rotation of those squares is just modulated randomly, increasingly randomly as we approach the bottom. And this is super interesting. I love how it sort of illustrates order and chaos all in the same image. I really like this piece. I might even get a print of it, but I'm not sure it's the type of creativity I have in mind. Here's a more recent example from Tyler Hobbs. This is from 2017. So this is the output of a program that actually simulates watercolor paint, which is really cool. So I'm impressed by this piece for many reasons. My favorite thing is that it was just created by code. It's really cool. But I'm not sure this is the type of creativity I have in mind. So here's a screenshot from something called Deeply Artificial Trees, which it's a short film. So this was the result of a neural network getting its hands on the joy of painting. So that used to be Bob Ross. So I'm really just scratching the surface here. Obviously, there are tons of examples of generative art from the past several decades. But what I didn't find was very many examples of what I was looking for. What I realized, I was looking for some sort of higher level creativity. Neural network art comes close, right? But it's not really that human, right? I have a hard time believing a person came up with this. And if they did, have a hard time believing they chose to share it if they came up. So emulating creativity is complex, but creativity itself seems pretty straightforward. I mean, so I thought. Isn't creativity just taking ideas and synthesizing new ones? Approximating human level creativity, totally intractable. Giving AI the ability to, develop taste and have the same sort of aesthetic values as a person, probably a pipe dream. But I wanted to see how far I could get anyway. So there are lots of ways to think about creativity, but I really like this quote. Creativity is just connecting things. When you ask creative people how they did something, they feel a little guilty because they didn't really do it. They just saw something. It seemed obvious to them after a while. So I like this quote. Perhaps creativity is just about making connections between things you kind of already know. I think there's something to that. So one common way to encode knowledge is as a set of objects and relationships between those objects. And these are sometimes referred to as concept graphs and knowledge graphs. I believe that creativity can largely be described as a set of operations on a concept graph. So, for example, finding an analogy is a matter of finding two sets of nodes with a similar relational structure. And I'm going to illustrate that in a moment. And those structures can be simple or complex. That's just one example, but just intuitively, I feel like creativity can be broken down that way. So let's see what happens. So green is the color as orchid is to flower. I assume most people understand why that's an analogy. This is a pretty easy example. Node A is a type of node B. So the next one seems easy, but human is to fingernail as tiger is to claw. So I think intuitively most of us feel like these two things are analogous, but can you explain why they're analogous? I think that's much more difficult. And if we can't explain why, we're going to have trouble implementing it. So here was my attempt to explain it in words. Node A has a multi-fingered appendage comprised in part by node B. That's actually kind of an inadequate description. It kind of gets at the heart of the matter, but it's kind of interesting that it's difficult to articulate, and yet I think most or all of us in this room would say in an instant, yes, those two things are analogous. So given that we talked about with concept graphs, how might we emulate creativity? So what if we map operations on the concept graph, like the one I just described, to operations on an image? So I'm going to give you just one example. So for a given object, what if we replace the background image with the location where you typically find that object? So the operation is start with the object and find a typical location, and then the transform that we're matching is replace background with that location. So what would happen in this simple example? And this is a manual example, but what would happen here? So this is a chicken on a plate. So at first glance, maybe this seems a little bit random, or maybe it seems like someone has a sick sense of humor. It's definitely whimsical, but it also kind of makes sense. It elevates this narrative that most people think of chickens just as food. I actually found this relationship in a real concept graph, though, and in addition to plate, the other locations include pizza, freezer, and oven. So not sure we would have done much better here. So we just talked about two simple transforms, and we can define as many as we want, and chaining these together gives us ever more complex images. So here's my proposed creativity algorithm. So you can start with a seed image. You can do instance segmentation to extract objects. You can run all permutations of available transforms on the recognized objects themselves. And then you can choose the ones with the highest score to simulate some notion of taste. And I'm going to talk about where we get the score from in a second, but why don't we try that? So here's how I try to implement that. So I mentioned previously that I'm using mask RCNN. And this is actually trained on a data set called COCO, Common Objects in Context. So basically, my artist is able to recognize 80 different objects, which isn't very many. So next, I cross-reference those recognized objects with ConceptNet, which is an open concept graph. And that gives us some of what I was just talking about, where we have this active concept graph that's actively maintained. We can try to run operations on it, and we can see what happens. So a quick note about scoring. ConceptNet for each object, or sorry, for each edge, includes a weight. So for example, between chicken and plate, there's a weight. So for scoring, I can compare something like chicken on a plate to something like chicken on a pizza, and I can come up with which one is better. So for my proof of concept, here are the transforms I decided to implement. So I implemented if all objects share a location, replace the background. If two objects have an analogy with two other COCO objects, remove the objects in the image and insert the COCO objects. If there's a round object, like a tennis ball, replace it with a random round object in COCO. And then finally, if two objects share an is-a relation, meaning they're the same type, isolate objects by removing all of the objects. So not two dogs, but more like two mammals. And for that last one, in case it's not obvious, there are two reasons that's there. So one is that focusing people's attention is a form of creativity. You're kind of choosing which part of the image to elevate. But the other thing is that it also enables more interesting transforms later in the pipeline. So for example, in one permutation, we have an is-a transform first, and then it isolates objects. Then when we run the first transform where when all objects have the same location, we replace the background, then that transform is going to find common objects much more frequently after that sort of isolation transform is run. And of course, maybe that will get thrown out, but it's worth evaluating so we can compare it against thousands of other permutations. Okay, so let's see how well this works. So in this example, we have a carousel. We have a bunch of animals on that carousel. We have some people in the background. There's a lot going on in this scene. This is a little bit of visual cacophony, tough even for a person to parse. So what do you think we'll get? So in this case, might be kind of hard to see in the projector. The elephant and the horse were actually pulled out of the original scene and rendered in front of a tent from a circus. So it sort of interpreted this elephant and horse as a live elephant and horse. But that's to be expected. You can't tell the difference between a fake horse and a real one. But this is actually a good illustration of that isolation transform I mentioned at play, because that wouldn't have happened because there are people. That wouldn't have happened unless we just pulled out the animals and explored what we could do with them. So in this next example, this is a photo of a hand model or something wearing a watch. So what do you think will happen here? So in case you can't see that, the artist decided to replace the face of the wristwatch with a stop sign. It's actually recognizing the watch face as a clock in this case. That's one of the Coco objects, and replacing it with a random round object. But this kind of works. It kind of works. This could be like a visual pun. It could be stopwatch, or it could be sort of it could have some higher meaning. It could be reminding us to stay present and not care so much about the time. But I really like this one. So there are a lot of failure cases, as you can guess. So this is a cat and a bird. And let's see what happens here. So you probably can't tell what's going on there. It took me a second too. So there's a baseball player in the middle, and there's a dog in the top right. And so what I notice is that the analogies produced by this data set are usually pretty strange. We're only able to recognize 80 objects, as I mentioned. And also the relationships in the concept graph just aren't that precise. And I think that's more a weakness of natural language processing in general than ConceptNet. But obviously the desire cats have for birds is very different from the desire people have for dogs. And this just doesn't make that much sense. And let's move on. So in this last example, we have someone delivering a forearm to a tennis ball. So what do you think is going to happen here? And that is a tennis donut. So this was probably the first image I saw when I got object replacement working, and it made me laugh out loud. It was an awesome experience. Okay, so just like other forms of generative art, this creativity isn't nearly 100% autonomous. Since I'm choosing the versions I like best, I genuinely don't know what I'm going to see, though, when I run this script, but I'm often amused. And each creation is sort of like a visual puzzle or riddle. And I'm also sort of retrofitting meaning onto the images after seeing them, right? I did program this to spit out titles, but they're kind of nonsensical at this point. But I think this is kind of similar to what we do, right? So we traverse our sort of internal concept graph, we find interesting structures, then we retrofit meaning based on how we see ourselves, how we see the world, right? There is no inherent meaning in the structure and our knowledge. It's all about the context that we add. So I don't know. I kind of feel like it somewhat faithfully recreates the creative process. So this started as a really tiny hackathon project, but as you can see, it turned into something much more. I never thought I'd take this tiny crazy idea this far. I learned a ton working on this, gained a much greater appreciation for art. But the big thing I realized is that iterating on software really is a lot like iterating on a drawing or a painting. With each incremental improvement, starts to take a little bit more shape. So while there's a lot more work to do before we see this stuff auction off at Sotheby's, or this artist has a huge Instagram cult following, I see those challenges as a call to action. I'm going to keep plugging away at it. So before I go to questions, I wanted to call out all the technologies I use for this. So there's OpenCV, which is open source. GPU image, open source. Mask RCNN is a technique devised by Facebook AI Research. I'm using Matterport's implementation of Mask RCNN. I think it's I'm actually not sure what Matterport is. Unity, ConceptNet, Open Concept Graph. You should check that out. And then finally Coco, which is maintained by Facebook, Microsoft, a lot of the big companies, and really is really important to computer vision research. So with that, I think I might have time for one or two questions if you have any. Right here? That's a fantastic question. So I think I need to automate myself. I did mention that I don't think that, I said something like, I think giving computer any sort of notion of aesthetics is a pipe dream. But the problem here is that there are so many combinations created that it is hard to find the really good ones. And this is actually a really simple version of the program where each transform is only applied once. And there are only 4 transforms, and they're very basic. But suppose you had 10, some of them are more advanced. So for example, you see an umbrella, and you make other objects rain. That's something I've been working on. All of a sudden, the complexity explodes every time you add a transform. And actually, as you can imagine, once I got to 4, all of a sudden this thing was taking seconds to run, and as you would expect. But yeah, I think it's a matter of sort of automating myself. But to actually answer your question, I don't think it'll ever be done. But yeah. I didn't consider that. One thing I have considered, though, is incorporating some notion of seeing understanding, which is somewhat similar to what you're saying, but not exactly. So if you guys aren't familiar, there's another very active area of research where we're training AI to basically look at a photo and extract, full sentences and really extract, full concepts. So that's as far as I thought about it, but it almost sounds like you're talking about like seeding with a word instead of an image, right? I hadn't thought about that, but I'm gonna try it now. That's a great question. I mean, I think I had the first idea like 4 years ago. I implemented the first version 2 years ago. And then, yeah, from there, I was exploring some business ideas. The iOS game was a business idea. Some of it was implemented specifically for the talk. I saw this as a really good opportunity to try out a lot of these more ambitious ideas about creativity. So that was kind of the timeline. But as far as finding the time, I mean, it's a matter of like closing Reddit and Hacker News. Literally. That's probably time. It's the next speaker here. All right. Thank you.